Hello again. Today we're going to be talking about how to calculate rates of change for contexts that have nothing to do with motion. All right, I'm just going to go through a couple of examples. The first one is Rex is studying for T hours, and we know that if he does, then he's likely to get a grade of G of T points on his math test. So the relationship between the study hours, T, and the expected grade, G, is given by that function there. G of T is negative 40e to the negative 0.2 T plus 100. So we're going to find the value of G prime of 5, and we're going to interpret the result, and we have to use correct units to do that. So if I take the derivative of G, I get 8 times e to the negative 0.2 T. Then when I plug in 5 into that, I get a value of 8e, which really doesn't mean anything in the real world, so I'm going to approximate that with a decimal point of 2.943. So I know that after 5 hours of studying, Rex can expect his grade to increase by 2.943 points per study hour. Okay, and that is an instantaneous rate of change. All right, we have a tenant in an apartment who wants to share the space to save money. The apartment is 1,200 square feet. So if P people live there, then the amount of space S that each person can have is given by S of P equals 1,200 over P square feet. Find the value of S prime of 5 and interpret the result, including correct units. So I take the derivative of 1,200 over P, and I get negative 1,200 over P squared. If I plug in 5, I get a value of negative 48. And what that means in context is that when the fifth person moves in, the amount of space decreases at an instantaneous rate of 48 square feet per additional person. So that's just talking about derivatives. Usually we do talk about motion, but there are times that we don't, and we need to talk about how to interpret those results. So a quick lesson on that. If you have any questions, please let me know, and I'll see you tomorrow.